Good evening. Continuously, we are seeing the lesson fluids. வாய்மங்கள் அதை பத்தி பார்த்துட்டு இருக்கோம். So far, what we have seen is the various types of pressure and the pressure exerted by a liquid column. All the things we have seen. Now, today, what we are going to see is these three topics. First is அடர்த்தி, அதாவது what is density அப்படிங்கிறத பத்தி பார்க்க போறோம். அப்புறம் மிதத்தல் மற்றும் மூழ்குதல், floating and sinking. அப்புறம் மிதத்தல் தத்துவத்தின் பயன்கள், application of principle of flotation. இதுல வந்து hydrometer and then lactometer. அதுல hydrometer பத்தி we are going to see extensively. What are all the types of hydrometer is available and how the hydrometer is functioning. Lastly, I will show you a video of how hydrometer is useful to us. Lastly, I will show the video. So let us go into the lesson. First, what is density? அடர்த்தினா என்ன அப்படிங்கறத just I will tell you in Tamil. ஒரு பொருளின் ஓரலகு பருமனுக்கான நிறை அடர்த்தி எனப்படும். அது இங்கிலீஷ்லயும் சொல்றேன், நெக்ஸ்ட் இங்கிலீஷ்ல இருக்கு, தமிழ்ல முடிச்சுட்டு இங்கிலீஷ்லயும் சொல்றேன். ஒரு பொருளின் ஓரலகு பருமனுக்கான நிறை அடர்த்தி யூனிட், அதாவது யூனிட் மாஸ். அதாவது இங்கிலீஷ்ல அடுத்து சொல்றேன். அடர்த்தியோட எஸ்ஐ அலகு என்னன்னு கேட்டீங்கன்னா கிலோகிராம் பெர் மீட்டர் கியூப் ஆர் கிராம் பெர் சென்டிமீட்டர் கியூப். இதன் குறியீடு ரோ படிச்சோம் நம்ம. அந்த லிக்விட் காலம், அதாவது ஹைட் ஆஃப் த லிக்விட் பிரஷர் எக்ஸர்ட் பை லிக்விட் காலத்துல the density of a liquid is called rho அப்படின்னு படிச்சோம். அதேதான் இதன் குறியீடு, அதாவது இதனுடைய குறியீடு ரோ. சரியா? ரைட். இதனுடைய சிம்பல் ரோ. Now in English, density is defined as mass of the substance per unit volume. Density is defined as the mass of the substance per unit volume. SI unit of density is kilogram per meter cube or centimeter per meter, gram per centimeter cube. And symbol of density is rho. சரியா? Okay. Next, how will you find out the density? அத எப்படி ஃபைண்ட் அவுட் பண்றது, அடர்த்தியை எவ்வாறு காண்தல் அப்படிங்கறத நம்ம இப்ப பார்ப்போம். சரியா? இப்ப what we have to do is 250 மில்லி கொள்ளளவு கொண்ட குடுவை, அதாவது flask, அத we have to take it and we have to weigh. First the flask has to be weighed as empty. So at that time the mass can be noted down. It is 80 grams. அது next அதாவது one flask to be filled with water and another flask to be filled with kerosene. Then also you have to again weigh and find out the now the weights, the added weights. After filling up with kerosene and water, we have to weigh that. சரியா? ஓகே. இப்ப தமிழ்ல சொல்லிடுறேன். 250 மில்லி கொள்ளளவு கொண்ட குடுவையை எடுத்துக்கணும். வெற்று குடுவை நிறை 80 கிராம். 80 grams is the weight of the empty flask. ஒரு குடுவையை நீராலும் மற்றொன்றை மண்ணெண்ணெயாலும் நிரப்பும். அவற்றின் நிறையை காண வேண்டும். Take 250 ml flask and mass of the empty flask is 80 grams and fill one flask with water and another flask with kerosene. Then find the mass of two flasks. Okay, this is the first step. Then இப்ப நீரால் நிரப்பப்பட்ட குடுவை நிறை is 330 grams. மண்ணெண்ணெய், அதாவது கெரோசின் ஊத்திருக்கோம் இல்லையா, மண்ணெண்ணெய் குடுவை நிறை is 280 grams. So from this we can find out what is the mass of water. Mass of water is equal to how much? 330 minus 80 is equal to 250. நீரின் நிறை 250 grams. அதே மாதிரி மண்ணெண்ணெயின் நிறை 280 minus 80 is equal to 200 grams. Mass of water is 330 grams and mass of kerosene filled flask is 280 milligrams. So now we are finding out the mass of water and kerosene separately. Mass of water is 250 milligrams, 250 grams and mass of kerosene is 200 grams. Now what we have to find out is mass per unit volume. ஓரலகு பருமனுக்கான நீரின் நிறை. ஓரலகு பருமனுக்கான நீரின் நிறை. This is the very basic formula. D is equal to, when you in your 7th standard book, if you see, they would have put a triangle. You just go and see your 7th standard book. These are all the basic fundamentals, because I told you, no, the speed, the speed and velocity, time and distance, and now this density, mass, volume. These two things are very basic things. This is not only asked in your syllabus. I told about in your future you will be writing some of the service commission exams like bank exams or any other TNPSC exams. This type of question will be there. Either you have to find out the density, and how they will ask whether this will float or this will sink. Like that, they will ask a question. They won't ask the question directly. They will give the data. Like that, problems also we will shortly work out. So they will ask like this. So kindly remember this very simple formula: D is equal to M by V, or V is equal to M by D. Whatever permutation combination you want, we can very well find out. So now ஓரலகு பருமனுக்கான நீரின். So use the formula D is equal to M by V. What is the mass? Mass is 250 milligram. Volume, how much? It is a 250 ml flask. So we filled with 250 milligram ml of water. So 250 by 250, that is equal to mass. Mass is expressed in gram, and this volume is expressed in centimeter. We will tell as cc. 1 cc, 2 cc. Doctor to point. Sometimes you would have gone to the doctor. The doctor, early in those days, the doctor used to tell 2 cc injection. Give 2 cc injection. 2 cc injection means 2 cubic centimeter. 2 cubic centimeter. Just 2 ml. Any injections they will give in cc. That is milliliter. That syringe itself is either it is 5 ml or 10 ml. So the doctor sometimes says 2 cc or 5 cc. Like that, the doctor used to tell. That is, cc means cubic centimeter. That is what the centimeter cube we have put. 1 gram divided by gram per 1 gram per centimeter cube. Now we have found out for water. It is coming as 1. Now, ஓரலகு பருமனுக்கான மண்ணெண்ணெயுடைய, what is that? 200 divided by 2. It is 0.8 gram per centimeter cube. Okay. So now this is for the English medium people. Mass per unit volume of water. Same formula, 250 by 250 is equal to 1 gram per centimeter cube. Mass per unit volume of kerosene is equal to 200 divided by 280 divided by 200 is equal to 0.8 gram per centimeter cube. Like this, you have to find out the density. Density, or they may tell sometimes it is relative density. Relative density means how much when compared to water, how much this is dense. Like that, or when compared to kerosene, how much dense it is. So if you know the data, but now it's a simple logic. If anything comes above 1, means if the density of the substance is above 1, means what? That that substance will sink in water. If it is below 1 means it will float in water. Same example is this. You would have seen during the rainy days, color like you react color Vibgyor spectrum, like color like spectrum in the road. Why it is happening? The buses and cars which are going, there will be some leakage of diesel, and that diesel is floating above the water. Both the diesel and water are immiscible. Immiscible na onnoda onnu kalandu karayadu. It is called immiscible in nature. They will tell in chemistry as immiscible in nature. So and the எதனுடைய டென்சிட்டி, வாட்டர்னுடைய டென்சிட்டியை விட இந்த ஆயிலுடைய டென்சிட்டி கம்மியா இருக்கு. அதனாலதான் என்ன பண்ணுது, அந்த வாட்டர் மேல ஆயில் மிதக்கு. சரியா? the oil is floating above the water. Okay, right. இதுதான் வந்து அடர்த்தி, அதாவது டென்சிட்டி. Okay, next what is floating and sinking? What is floating and sinking? What is floating and sinking? மிதத்தல் மற்றும் மூழ்குதல். சரியா? ஒரு பொருளானது ஒரு திரவத்துல மூழ்குவது அல்லது மிதப்பது, அந்த குறிப்பிட்ட திரவத்தின் அடர்த்தியோடு பொருளின் அடர்த்தியை ஒப்பிடுவதன் மூலம் அறியப்படுகிறது. இப்ப நான் சொன்னதுதான், whether an object will sink or float in a liquid is determined by the density of the object compared to the density of the liquid. Okay, what I told, the density value, you have got the density of water is 1. If anything comes above 1, if a substance is density is above 1, that will sink in water. If the substance density is below 1, that substance will float in water. Okay, this is the simple logic. So a wooden log, what will do? A wooden log will float, but a stone is having a density much higher than water, so a stone will sink. This is the routine example. That is the smallest example, common example, which I can tell it to you. So the logic is simple. If the density of the liquid is lower than the substance, lower than any other substance, lower than the solid will float. If the density of the liquid is more than that of the solid, then the solid will float. You know, everybody would have seen mercury, and you would have handled mercury also. See, if you get any chance, if you go to the, now the schools are open, go to the laboratory and ask your teacher. See, mercury, if it is kept in a bottle, like an ink bottle, if it is kept, it will be very heavy. So 13.6 is the specific gravity or the density of mercury. So if you this is denser than iron. So if you put iron, or if you take an iron piece and if you pour mercury in a beaker, and if you put iron will float in mercury. So this is the relationship between the density and floating. This is the relationship between density and floating. Okay, it's a very simple thing. Please understand, it's a very simple thing. Please understand. Okay, whether an object will sink or float in a liquid is determined by the density of the object compared to the density of the liquid. Okay, next. Application of the principle of floating. Application of the principle of floating. What is the major application of principle of floating? The திரவம் on hydrometer அப்படின்னு சொல்றோம் இல்லையா, ஒரு எந்த ஒரு லிக்விடோட அடர்த்தி, அதாவது அதனுடைய டென்சிட்டி கண்டுபிடிக்கணும்னா அது எப்படி கண்டுபிடிக்கணும்னா இந்த திரவமான், அதாவது ஹைட்ரோமீட்டர் வச்சு நம்ம கண்டுபிடிக்கணும். ஸோ திரவத்தின் அடர்த்தியை மற்றும் ஒப்படர்த்தியை நேராக அளப்பதற்கு பயன்படுத்தப்படும் கருவி திரவமான். இது மிதத்தல் தத்துவப்படி வேலை செய்யும். It is working as per the principle of flotation. Okay, what is the flotation principle? That is also in my next slide I will show you. So a direct reading instrument used for measuring the density and density of a liquid is called a hydrometer. It works on the principle of flotation. It works on the principle of flotation. What is the principle of flotation? This is the principle of flotation. திரவத்தில் மூழ்கியுள்ள திரவமானியின் பகுதியினால் வெளியேற்றப்பட்ட திரவத்தின் எடை திரவமானியின் எடைக்கு சமம். தமிழ்ல சொல்லிட்டேன், இங்கிலீஷ்ல. The weight of the liquid displaced by the immersed portion of the hydrometer is equal to the weight of the hydrometer. இது நம்ம we are going to study Archimedes principle. That is also the same. What is the thing is, see, if you just have one beaker which is having a beak, that is just I'll show the instrument also in the next class. And if you put a weight like any stone or any other material, if you put inside, the water will get displaced, water will come out. You can collect that water, and if you weigh that water and this stone, the displaced amount of water will be equal to displaced amount of water weight is equal to the weight of the stone. That is the Archimedes principle. That same flotation principle is, by the way of flotation principle, this hydrometer is working. This hydrometer is working based on the flotation principle. Weight of the liquid displaced by the immersed portion of the hydrometer is equal to the weight of the hydrometer. திரவத்தில் மூழ்கியுள்ள திரவமானியின் பகுதியினால் வெளியேற்றப்பட்ட திரவத்தின் எடை திரவமானியின் எடைக்கு சமம். Okay, this is the very basic principle. This is the basic principle of flotation. Based on this only, next in your portion, laws of flotation is also there. Based on that only, ships are built. Ships are built based on the laws of flotation. Okay, so this is the basic things. Kindly remember. Now, I will tell about structure of a hydrometer. Structure of a hydrometer. Just I will show it to you. It's in the book, as well as I will show you one more that picture also. Okay, just we just see this is the hydrometer. See you, most of you would have seen a pipette in all your classes. In the laboratory you would have seen your pipettes. It will be like a pipette, this pipette, but the pipette will be open. So it will be a pipette like structure, and it will be closed like this. It will be closed like this, and inside this, if you see, there will be some lead pellets. Lead pellets or mercury will be there. Okay, mercury will be there. And here, this portion, this portion, this long portion, you will get a lot of readings. Lot of readings will be there, and here they have enlarged it and given the readings were given. So with the eye, we can see like this. You can see like this, so that you can note down the density of the liquid. You can note down the density of the liquid. This you would have seen sometime. You would have visited the petrol. When you are putting petrol, one petrol bunk employee will be taking the petrol out in a measuring jar, and he will put one instrument. Next time if you go, you just watch that. What is happening? Because why these applications, I will tell you. This you remember. This you remember. Or else, if you are in a village, this milk cooperative societies will be there. They will be measuring the density of the milk, how much creamy, or whether they have added water or anything is there. For that, they will be conducting this. So this is the structure of the hydrometer. Just you see this, then I will tell you about the wordings. Then only you will be able to better correlate the things what I. Okay, so this is the structure. It will be like a pipette, like this, and finally this floor, this base will be closed, and it will be like a sharp edge. Inside this, there will be lead pellets, or there will be mercury. Earlier in those days, in that hydrometer, that is the lactometer, shellac, that they used to fill it. Some lightweight materials they used to fill it. Nowadays they are filling it with lead shards, or it is filled with mercury. Okay, now I will explain. You please remember this these two pictures, and just I will explain. Kindly follow. See, திரவமானியானது அடிப்பகுதியில் கோள வடிவத்திலான குடுவையும் மேற்பகுதியில் மெல்லிய குழாயும் கொண்ட நீண்ட முளை வடிவ தண்டை கொண்டுள்ளது. This consists of a cylindrical stem having a spherical bulb at lower end and narrow upper end. Okay, again, once again, I will show it to you. Once again, I'll show it to you. So this consists of a cylindrical stem. You see the cylindrical stem and having a spherical bulb. Spherical bulb at the lower end and a narrow upper. Spherical bulb at the lower end and a narrow upper end. And you see a narrow upper end. You see a narrow upper end. This is how hydrometer looks like. And one more. This is a picture in your book. One more. This YouTube. You can see a lot of figures. Just I will show that also. This is a you would have seen, this is the hydrometer. It will be like this. It will be like exactly like a pipette. Okay, it will be like this. So this portion will be immersed in the liquid, and this is where you can get the readings also. Where you can take the readings also. Okay. So now this consists of a cylindrical stem having a spherical bulb at lower end and narrow upper end. Now you see குழாயின் அடிப்பகுதியில் பாதரசம் அல்லது காரிய குண்டுகளால் நிரப்பப்பட்டுள்ளது. பாத்தீங்க இல்லையா, கீழே ஒரு சிகப்பா ஒரு இது இருந்தது. Again just sorry, just I will show it to you again. Just you are seeing, you know, this is a lead or lead pellets or you can see either it will be filled with lead pellets or it will be a mercury. Okay, it will be mercury. Okay. Okay, next. So the what we have to do is இது திரவமானி மிதப்பதற்கும் திரவங்களில் செங்குத்தாக நிற்பதற்கும் உதவுகிறது. The lower spherical bulb is partially filled with mercury or lead shards. This helps the hydrometer to float or stand vertically. It is very simple understanding. It will very much helps to float or stand vertically. When it float or stand vertically only, we can take the readings. So first we have to very carefully immerse that, and after some time the great care has to be taken. It has to float. It should not touch the sides of the glass portion, that is the beaker or the measuring glass which we have taken. It should not touch. So it will exactly, it should float like that. It will be inserted into the liquid. Okay, next. மேலே உள்ள குழாயில் அளவீடுகள் உள்ளதால் திரவத்தின் ஒப்படர்த்தியை நேரடியாக அளவிடலாம். The narrow tube has markings so that the relative density of a liquid can be read directly. So on the value எது வருதோ அதை வச்சு நம்ம we can find out the density of the liquid directly. So find out the density of the liquid directly. This is the various types of hydrometers which we have seen. This is the type of various types of hydrometers we have seen, and you could see various uses of how it can be, readings can be taken. திரவமானியில் அளவிடுதல், how the measuring with hydrometer. So I have told you, know, like the petrol bunk, they will pour the petrol in the measuring glass and they will put the instrument inside and they will read the readings like that. Again I am showing you. So they have put the bulb, this is the vessel, and in this they have taken the petrol and they have put the meter inside. They have put the meter inside. And see this instrument. This is the instrument and they have put inside. This will get floated, and up to this level, if the instrument is getting immersed in the liquid means, so this reading can be taken. Whatever reading is coming as can be noted, and that can be the density of the liquid. That can be the density of the liquid. One more time, the book figure also I will just show it to you. You just see this is put inside. So now they have with your eye you can very well note this reading like 28 or 29 like that. You can note down the density or the relative density of the liquid. Okay, right. Next is so குழாயின் அளவீடுகள் திரவத்தின் மேற்பகுதியை தொடும் அளவு திரவத்தம்பத்தின் ஒப்படர்த்தி ஆகும். I showed you the reading against the level of the liquid touching the tube gives the relative density. So this is the how you find out density. Now திரவமானியின் பயன்பாடு. Various uses of hydrometer. This hydrometer is having wide variety of application. இதை பயன்பாட்டிற்கு ஏற்றபடி அளவு திருத்தம் செய்து ஃபர்ஸ்ட் என்ன பண்ணலாம், பாலோட அடர்த்தியை கண்டுபிடிக்கலாம். பால் மானி, இட்ஸ் கால்ட் லாக்டோமீட்டர். தென் ஒன் சாக்ரோமீட்டர் மீன்ஸ் சர்க்கரையோட அடர்த்தி. இப்ப இந்த ஹெல்த் டிபார்ட்மெண்ட்ல இருந்து வருவாங்க. முன்னெல்லாம் வந்து இந்த நம்ம கூல் ட்ரிங்க்ஸ் இருக்கு இல்லையா, அந்த கூல் ட்ரிங்க்ஸ்ல they will mix saccharin instead of sugar, they will mix saccharin. So they will measure with this type of hydrometer, and they will find out whether they have genuinely used sugar or they have made any adulterations. Same way, petrol bunks periodically that employee will check, and the officials from the oil company also will check, because some petrol bunks they will mix kerosene or some other adulterary materials into the petrol, so that what will happen, the efficiency of petrol will come down and our vehicles will develop snag. So in order to avoid that, with these instruments, the exact they will tell us specific gravity. They will use one more term called the specific gravity. If you look at the petrol bunk, they will put the specific gravity of petrol, time taken, everything will be there in your board. So when you go to the petrol bunk, kindly note this. And also alcohol meter, that is, see, earlier, nowadays the syrups, the cough syrups and other syrups which we are taking for medical purposes, they are all alcohol. Earlier days, those medicines will contain alcohol, particularly paracetamol syrups and cough syrups. All the digestive enzymes, everything will contain alcohol. And what was certain done, alcohol is what I say, it's a substance for drinking purpose they are using. One more use of alcohol is small quantity, allowable quantity in medicine. So periodically the health officials will check the level of alcohol in those type of syrups, cough syrups, paracetamol syrups. If it is find above the level of allowed ppm, then it is an offense. They will book the companies, they will fine the companies, medical companies. So these are all the application of hydrometers. இதை பயன்பாட்டுக்கு ஏற்றபடி அளவு திருத்தம் செய்து பாலின் அடர்த்தியை காணும் பால்மானியாக பயன்படுத்தலாம், சர்க்கரை அடர்த்தியை காணும் சர்க்கரை மானியாக பயன்படுத்தலாம், சாராயத்தின் அடர்த்தியை காணும் சாராயமானியராகவும் பயன்படுத்தலாம். So hydrometers can be calibrated for different purposes. Lactometers can measure the creaminess of milk. அந்த lactometerல பாத்தீங்கன்னா தெரியும், அதை இந்த நீங்க பாப்பீங்க, you will just see the readings. With that you can very well appreciate the usage of hydrometer. So saccharometer for the density of sugar, alcohol meter for measuring the level of alcohol. So these are all the things which we have seen today in the portion called fluids. வாயுமங்கல்ல இதெல்லாம் நம்ம பார்த்தோம். So just hold on for me. This is the thing which we have come across today. So kindly go through your lessons. They are very much useful to you. Thank you very much. வாழ்க பாரதம், வெல்க தமிழகம். Thank you very much.
நன்றி, வணக்கம்.